radius of gyration. The moment of inertia of any object depends upon mass of that object and distribution of mass from or around the given axis of rotation. Here, the position of axis of rotation plays very important role in the moment of inertia. Consider a rigid body of mass m or a symmetric object of mass m. It consists of the number of particles m1, m2, m3 up to the mass mn. They are situated at perpendicular distance, say r1, r2, r3 up to the distance rn from the axis of rotation. So suppose this is the axis of rotation, about this mass are getting rotated. So the moment of inertia of such system is given by I is equal to summation of mi ri square, where I is ranging from 1 to n. Now we will convert this whole rigid object into the point mass object so that its mass will not change. And now we have to keep this point object at a certain distance from the axis of rotation so that the moment of inertia of such system will be same as that of the moment of inertia of this rigid object. So let us see that we kept this moment point object at a perpendicular distance k from the axis of rotation so that the moment of inertia of this system is same as the moment of inertia of this previous system. So we can write here the I is equal to mk square, where m is the mass of that object, which is same as the previous system, and k is a perpendicular distance about a given axis to the point which would have the moment of inertia same as the body's actual distribution of mass, and hence we can find it out that the position of this axis of rotation can be changed, and in this whole body object we can get one such point where the whole mass of this body is supposed to be get concentrated at a one particular distance k, so that the moment of inertia about this axis will be same as the moment of inertia of this previous system. So we can write here the moment of inertia is equal to mk square is equal to moment of inertia of a previous system, that is nothing but summation of mi ri square, where I is ranging from 1 to n. It means that the moment of inertia of a object is effectively at a distance k from the given axis of rotation, and here k is known as radius of gyration. K is defined as the radius of gyration of the object about the given axis of rotation. So the moment of inertia of such system is given by I is equal to mk square. Hence, the radius of gyration k is equal to square root of I upon m. SI unit of the radius of gyration is meter. Larger the value of k, further is the mass from the axis. Radius of gyration or guy radius of a body about an axis of rotation is defined as the radial distance or the perpendicular distance about a given axis to the point which would have a moment of inertia the same as the body's actual distribution of mass if the total mass of the body were concentrated. Simply, gyration is the distribution of the component of an object. Physical significance of K, that is radius of gyration. Radius of gyration is a measure of distribution of mass about a given axis of rotation. If the particles of a body were distributed close to the axis of rotation, the radius of gyration is less. If the particles are distributed away from the axis of rotation, the radius of gyration is more. The knowledge of the mass and radius of gyration of a body about a given axis of rotation gives the value of its moment of inertia about the same axis, even if we do not know the actual shape of a body. This is a table of moment of inertia and radius of gyration of such or some objects like a thin rod of length L, ring of radius R, or the same ring of radius which is rotating about a different axis, or the circular disc of a R, and the position of the axis of rotation is given in this column. This is another table which also gives us the moment of inertia of a circular disc, also the radius of gyration of such some object like a circular disc, hollow cylinder of a radius r, solid cylinder of a radius or solid sphere, and the hollow sphere which are rotating about a different axis. That axis is given in this column. So learn it. Thank you.